Welcome back, everybody. Apologia, 8th grade, physical science, week 9, day 1, textbook pages 133 and 134, notebook pages 104 and 105. Okay, so we spent the last two videos discussing chemical bonding. Specifically, we talked about ionic bonds and covalent bonds. And just a little refresher, an ionic bond is a chemical bond formed between oppositely charged ions. Groups 1A, 2A, 3A, and 7A transfer electrons to form ionic bonds and make ionic compounds. And then covalent bond is a chemical bond in which two atoms share one or more pairs of valence electrons. And those are groups 4, 5, and 6. They tend to share their electrons. So before we leave the topic of types of bonds, I want to mention the two other types. The first type of bond involves metals. Most metals have a very low attraction for electrons, which is why they give up their electrons so easily to become positive ions. Because of this, the valence electrons of metals move more freely between atoms of the element than valence electrons of nonmetals. These freely moving valence electrons are what makes metals good conductors of electricity. Again, they're moving electrons. The attraction of the positive metal ions to the valence electrons of neighboring metal ions is called a metallic bond. The metal ions and the constantly moving valence electrons form a lattice-like structure held together by the metallic bonds. This is also why metals are malleable. And again, hopefully you remember malleable means they can bend without breaking. Okay. So I wanted to further explain that, and I found a great answer on Encyclopedia Britannica. Explain what a metallic bond is. A metallic bond is a force that holds atoms together in a metallic substance. Such a solid consists of closely packed atoms. In most cases, the outermost electron shell of each of the metal atoms overlaps with a large number of neighboring atoms. And as a consequence, the valence electrons continually move from one atom to another and are not associated with any specific pair of atoms. In short, the valence electrons in metals, unlike those in covalently bonded substances, are non-localized, so they're capable of wandering relatively freely throughout the entire crystal. The atoms that the electrons leave behind become positive ions, and then the interaction between such ions and valence electrons gives rise to the cohesive or the binding force that holds the metallic crystal together. The second type of bond involves polar molecules. Remember, polar compounds such as water are molecules that have a partial negative charge on one side and a partial positive charge on the other side of each molecule. And because of the partial charges, one water molecule is attracted to 4 other water molecules. You can sort of see this in this figure. All right. The positively charged hydrogen side of one water molecule is attracted to the negatively charged oxygen side of another water molecule. So here we go. Here's a partially charged hydrogen. You can see it says it's partially charged, positively charged. It is attracted to the partially negative charged oxygen. And again here, we have this oxygen, which is partially negatively charged. It is attracted to this hydrogen, which is partially positive charged. This force of attraction is called a hydrogen bond. Now, we should have seen this when we did the experiment 4.1. Because of the hydrogen bonds between the water molecules, the stream of water stayed together and it actually bent towards the charged balloon. It was a slight bend, but it did bend. Unlike the other bonds we've talked about, hydrogen bonds are bonds that form between molecules, not between atoms. They are weaker bonds than covalent or ionic bonds, but strong enough to make molecules stick together, and they are very important. Hydrogen bonding occurs in any polar molecule in which positive hydrogen atoms are attracted to negative atoms of nearby molecules. But it is hydrogen bonds that allow water to have the many wonderful properties it exhibits. All right, on your own, which of these elements does not bond to form molecules? Is it oxygen, chlorine, neon, or nitrogen? I hope you would know right away that the answer is C, neon. Neon is a noble gas, so it has a stable outer shell. It has a stable electron configuration, so it does not bond. Your own 4.7, what attraction holds atoms together in covalent bonds? The attraction between the shared electrons, and remember electrons are negatively charged, and the positively charged protons in each nucleus, that attraction is what holds the atoms together in a covalent bond.